For nearly 40 years, we've been relying on data from 1986 to understand Uranus. But as it turns out, that was a mistake. The James Webb Telescope has now finished a 15-hour deep dive into the planet's atmosphere, and the correction we're seeing is massive. While most of us were taught to see a featureless, frozen ball of gas, this new data is revealing a reality that contradicts everything in our current textbooks and proved our science is decades out of date. The first thing this 3D map revealed is that Uranus's magnetic field is physically lopsided. Our magnetic field is mostly aligned with our north and south poles, but Uranus is showing its offset by nearly 60 degrees and doesn't even pass through the center of the planet. This creates a chaotic environment where the planet's magnetic forces are literally dragging the upper atmosphere into asymmetrical shapes. Imagine a magnetic shield that's been pushed and pulled until it's completely warped. That's what the Webb telescope just captured for the first time in history. But the real correction comes from the auroras. Uranus was said to have simple, circular polar lights like Earth or Jupiter. However, by looking up to 5,000 kilometers above the cloud tops, Webb found two massive, glowing infrared bands that don't stay at the poles. We previously viewed these as faint flickers of light, but they are actually deep, three-dimensional energy columns that act like a giant radiator. Because the planet's magnetic field is so off balance, these auroras sweep across the planet in complex and distorted patterns that defy everything we know about planetary alignment. As they move, they create massive heat peaks thousands of miles high. The 3D map proves that the energy is being dragged and stretched by a magnetic field so lopsided it shouldn't be stable. This atmospheric turbulence hides a deeper contradiction. While these magnetic radiators pump heat into the upper layers, the rest of the planet is doing the exact opposite. Observations show a steady, unexplained drop in Uranus's overall temperature, reaching levels far below what any thermal models predicted. It's a paradox that has left researchers baffled. The planet generates massive amounts of localized energy through its auroras, yet its core heat is vanishing into space at an accelerating rate. The timing of this discovery is critical. As the James Webb Telescope peels back these layers, it's showing that Uranus is entering a phase of its 84-year orbit that has never been captured with modern instruments. Everything recorded during the 1986 flyby was merely a snapshot of a single, quiet moment. Now, as the planet tilts toward a new seasonal extreme, it's clear the said-to-be ice giant is a much more energy-depleted machine than originally imagined. This brings us to the most significant correction of all, the name itself. Labeling Uranus an ice giant implies a frozen world defined by its distance from the sun. But the James Webb data shows a planet that behaves more like a massive, failing thermal engine. Between the lopsided magnetic fields dragging the atmosphere into 3D shapes and the mysterious internal cooling, the ice part of the equation is becoming harder to defend. We are looking at a dynamic, high-energy system that is actively shedding its own heat into the vacuum of space. If a planet has glowing infrared radiators thousands of miles high and a core that is cooling faster than physics can explain, the old labels no longer apply. The discovery of this 3D structure shows that Uranus could be a cold rock at the edge of the system. Now, if the 1986 data for Uranus was this dangerously incomplete, it raises a massive question about the only other planet in its class, Neptune. We've traditionally paired these two worlds together as twin ice giants, assuming they shared the same frozen composition. However, Neptune is actually more active, radiating over twice as much heat as it receives from the sun. If Uranus, the quiet twin, is secretly a high-energy thermal engine with 5,000-kilometer radiators, then our current model for Neptune is likely even further from reality. Uranus reveals that these infrared structures are deep, vertical heat transport systems. Neptune's wind speeds regularly exceed 1,200 miles per hour. The friction between atmospheric layers should be generating even more extreme thermal signatures than what we just saw on Uranus. This gap in our understanding suggests Neptune's famous storms, like the Great Dark Spot, aren't just surface-level weather events. If Uranus has a magnetic field physically carving out its atmosphere, Neptune's much stronger magnetic environment is likely doing the same thing, just with more violence. When you think about it, we've always struggled to explain why Neptune is so much hotter than it should be. This might be a scenario where that heat is being sparked by the same magnetic friction we just found on its twin. This shared instability raises a much bigger question about the foundation of these worlds. We've always been told that Uranus is tilted on its side because of a massive crash billions of years ago. The problem is that a frozen planet stays put. This thing is a liquid mess of magnetic friction and shifting heat. If the interior isn't a solid core but a moving soup, then that 98-degree tilt is a process that might still be happening. The center of gravity is likely wandering as those internal radiators shift and the magnetic field slips. If it hasn't finished falling over, then every calculation we have for the gravitational stability of the outer solar system is essentially a guess. This leaves us staring at a huge blind spot. If we've been this wrong about the planet's basic physical state, you have to wonder what else is tucked away in that dark, pressurized soup. There could be potential for materials that shouldn't exist according to our current chemistry. Or there could be internal weather patterns that are completely invisible to us because we've only ever looked at the surface. The problem is that you can't see these internal weather patterns from a telescope 3 billion miles away. We've reached the limit of what a long-distance snapshot can tell us. The only way to see past the blue veil is to use the spacecraft like a depth charge. That probe's final moments would be the first time we actually see the gears of the outer solar system in motion. Up until now, we've been looking at a snapshot and calling it a planet, but the reality is much more volatile. A liquid shifting interior means the tilt is a process that never stopped. If you enjoyed this explanation, subscribe to the channel for more updates on the physical reality of our solar system, or if you want to learn something new that's happening in space.